So the next section we're going to talk about is linear functions and graphing with a table. So we're going to use the equation to fill in the table and plot the points, then determine if the graph represents a linear relationship. So for example 1, our equation is y equals x minus 3. And we're given all of the left side of the table filled in, but we need to fill in the right side. So if my equation is y equals x minus 3, I have to take all of these different x values and substitute them into my equation to solve for y. So for the first one, when x equals -1, I'm going to rewrite the equation y equals, but instead of x, I'm going to go ahead and substitute in this x value. So this row is -1, so instead of x, I'm going to write -1 and then minus 3. And then -1 minus 3 is -4. So that means that's my y value for that row of the table. And then the next one, I'm going to rewrite the equation again. Y equals x minus 3, but instead of x, I'm going to substitute in 0 because that's my x for that row. So equals 0 minus 3. And then 0 minus 3 is -3. So that's my y value for that row. Next, I'm going to substitute in x equals -2. So y equals, instead of x minus 3, it's 2 minus 3. 2 minus 3 is -1. So that's my y value for that row. Next, I'm going to substitute in x equals 5. So my equation is y equals 5 minus 3. 5 minus 3 is 2, so y equals 2. And then the next one I'm going to substitute in is x equals 6. So y equals 6 minus 3. And then 6 minus 3 is 3, so that's my y coordinate. Once we fill in this table, this gives us a list of points. So I'm going to write these points in x, y order. So the first point is my first x, -1, and the y that goes with it. So -1, -4. The next one is 0, -3. The next one is 2, -1. The next one is 5, 2. And the next one is 6, 3. Now we're going to plot these 5 points. So when you're graphing, we always start at 0, 0, and then if x is positive, if the first number is positive, we're going to go to the right. If x is negative, we're going to go to the left. For y, if y is positive, the second number, I'm going to go up. If y is negative, I'm going to go down. So my first point is -1, -4. So from 0, 0, I'm going to go left 1 for -1, and then I'm going to go down 4 for -4. The next one, 0, -3. So since the x value is 0, I do not have to go left or right at all. I just have to go down 3 for the -3. For 2, -1, that means I'm going to go right 2 and then down 1 for the -1. For 5, 2, I have to go right 5 and then up 2. For 6, 3, I have to go right 6, up 3. So here's the graph that matches our table, or that represents our table. And then if we want to determine if a graph represents a linear relationship, we have to decide if all of the points line up in a straight line. So you can use a ruler if you can't see it right away, but these all fall in a straight line, meaning it's not like one direction this way and then we get really steep. This is all in a straight diagonal line, so that means it's a linear relationship. Okay, for the next table, y equals 2x. So I have my x's filled in. I need to fill out my table, get my points so that I can figure out if I have a linear relationship or not. So for y equals 2x, I'm going to rewrite that equation in my y column. Y equals 2 times x, but instead of x, I'm going to plug in -2. So 2 times -2 is -4. So -2, -4 is my first point. And then when x equals -1, my equation is y equals 2 times x. Instead of x, I'll plug in -1. So 2 times -1. 2 times -1 is -2. So -1, -2 is my next point. When x equals 0, my equation becomes y equals 2 times 0 instead of x. And then 2 times 0 is 0. So my next point is 0, 0. And then when x equals 1, my equation becomes y equals 2 times 1. 2 times 1 is 2. So 1, 2 is my next point. And then when x equals 2, my equation becomes y equals, instead of 2 times x, it's now 2 times 2. And then 2 times 2 is 4. So 2, 4 is my next point. So 1 point, -2, -4. The x value is -2, the right value is -4. So that means I'm going to go left 2, because the x value tells me left or right. And then down 4, because the y value tells me up or down. So left 2, down 4 from 0, 0. So left 2, down 4. And then for -1, -2, I'm going left 1, down 2, left 1, down 2. For 0, 0, that's right on the origin. For 1, 2, I'm now going right 1 since it's positive, and up 2 since that's also positive. So right 1, up 2. And then for 2, 4, I'm going right 2, up 4. So right 2, up 4, because they're both positive, so they're both going in the positive direction. And then to determine if it's linear, see if my points line up in a straight line, or you can double check it with a ruler, and they do. So this is linear. Number 3, my next equation is y equals -x plus 1. So I have my x values filled in. I'm going to start plugging them in and finding the y values that go with them. So my equation is y equals negative, we have to be careful about this negative x plus 1. So negative x is going to have the negative out in front, and then because x is -5, that'll go in parentheses. And then plus 1. -5 turns into +5 plus 1, and because anytime you have a double negative like that, it turns into a positive. And then the next one, when x equals -3, my equation becomes y equals, this negative is out in front, and then the -3 goes in parentheses. And then plus 1. So -3 turns into +3 plus 1, which is 4. And then when x equals -1, my equation becomes y equals -x. So there's no -1 here, it's just +1. So this turns into -1, and then plus 1. -1 plus 1 is 0, because they're just opposites. And then when x equals 2, my equation becomes y equals -2 for x plus 1. -2 plus 1 goes up to -1. And then when x equals 4, if I substitute that into my equation, y equals -x, so -4 plus 1. And then -4, if I go up 1 from there, I'm up to -3. So now I have all 5 of my points. I can start to graph them. So -5, 6, -3, 4, 1, 0, 2, -1, and 4, -3. So for -5, 6, I'm going left 5 since x is left or right and y is up or down. So left 5, up 6 since this is positive. left over to 5, up to 6. The next point, negative 3, 4, I'm going left 3 and then up 4. So left 3, up 4. For 1, 0, I'm going right 1, and I'm not going up or down at all since y is 0, so I'm just going right 1. And then 2, negative 1, I'm going right 2, down 1. 4, negative 3, I'm going right 4, down 3. So right over to 4 and then down to 3. And then I have to figure out if these are linear, they fall in a line. Looks like they do, so this is a linear relationship. The next type of problem we're going to do is determine if specific points are solutions to an equation. So our equation is y equals 2x plus 1. In order to determine if a point that you're given is a solution to the equation, you have to plug those points in for x and y and see if the equation is true. So since my point is 6, 13, I'm going to substitute in 6 where x is and 13 where y is and see if my equation ends up being true. So the equation y equals 2x plus 1, so I'm going to put 13 in for y. So 13 equals 2x, so 2 times 6 in this case, since I'm putting 6 in for x, so 2 times 6 plus 1. I'm just going to simplify the right side and see if I end up with 13. So 13 equals 2 times 6 is 12 plus 1, and then 13 equals 12 plus 1 is 13. So since that's true, this is a solution. One more time, because we ended up with the same number on both sides and a true statement, it is a solution. And then for B, we're checking the point negative 2, 4. So negative 2 is going in for x, and 4 is going in for y. So our equation y equals 2x plus 1, 4 will go in for y. So 4 equals 2x will turn into 2 times negative 2, and then plus 1. And then we're just going to simplify the right side to see if it ends up as 4. You'll just simplify whichever side has the things that you can simplify, I guess. So 2 times negative 2 is negative 4 plus 1. And then 4 equals negative 4 plus 1, so negative 4, and then we go up 1 to negative 3. So 4 is not equal to negative 3, so this point is not a solution to this equation.